Hello and welcome to this lesson on calculating the RF value in chromatography and its significance in identifying compounds. In today's lesson, we will understand how to calculate the RF value in chromatography, explore factors affecting RF values, and explore the significance of the RF value in identifying compounds. So far, you have an intuitive understanding of chromatography and its stages. You are aware of how chromatography is used to separate different substances based on their movement through a medium. Building on this foundation, today's lesson will enhance our chemical understanding by introducing the concept of the RF value, a crucial tool in helping us identify and analyze various compounds through chromatography. Let's get started. The RF value, or retention factor, is a numerical value that represents how far a substance travels in relation to the solvent front in chromatography. It provides a way to quantify and compare the movement of different substances on a chromatogram. RF values also allow us to identify substances by comparing their RF values to known standards. To calculate the RF value, we use the following formula: distance moved by substance divided by distance moved by solvent. The distance traveled by the substance is measured from the baseline, the original spot where you applied the mixture, to the center of the spot formed by the substance on the chromatogram. The distance traveled by the solvent is measured from the baseline to the solvent front, which is the furthest point reached by the solvent on the paper. The RF value should always be a number between 0 and 1. Suppose, for example, you have this chromatogram and we want to find the RF values of the red and blue spots. We would first start by measuring the distance from the baseline to the solvent front. In this case, it is 8 centimeters. Next, we can measure the distance from the baseline to the center of the red spot. This comes to 4 centimeters. Thus, we can calculate the RF value of the red spot as 4 divided by 8 equals 0.5. We can do a similar process for the blue spot. In this case, the distance from the baseline to the center of the blue spot is 6 centimeters. Hence, the RF value is 6 divided by 8 equals 0.75. The blue spot has a higher RF value than the red spot, indicating that it has traveled further and is therefore more soluble in this specific solvent. There are different factors that can affect the accuracy of the RF value. First up, types of solvents. Different solvents can cause substances to travel different distances on the chromatography paper. This is because each substance dissolves differently in various solvents. For example, a substance might dissolve very well in one solvent and travel far, but not dissolve as much in another solvent and travel a shorter distance. This will affect its RF value, so using the same solvent throughout an experiment is important to get consistent results. Next is type of chromatography paper. The material and properties of the stationary phase, in this case, the chromatography paper, can also influence how far a substance travels. Some types of paper may hold onto substances more tightly, slowing them down, while other types may allow substances to move more freely. This difference will impact the RF values. Finally, temperature. Temperature can change how substances interact with both the solvent and the paper. At higher temperatures, substances might dissolve more easily in the solvent and travel further, while at lower temperatures, they might not move as far. As a result, changes in temperature can affect the RF values, so keeping the temperature stable during the experiment is essential. Because of these factors, it's important to keep the experimental conditions the same, such as using the same solvent, type of paper, and temperature, if you want accurate and reliable RF values. If any of these factors change, the RF values may not be comparable, and your results could become less accurate. Each compound has a characteristic RF value under specific conditions, like the type of paper and solvent used. By comparing the RF values of unknown substances to those of known substances, you can identify the components of a mixture. For example, suppose you performed chromatography on an ink sample and suspect it contains the dye red 40. You used a chromatography paper with ethanol as the solvent. After running the chromatogram, you obtained the following measurements. The spot for the unknown substance traveled 2.8 centimeters from the baseline. The solvent front traveled 5.6 centimeters from the baseline. This gives an RF value of 2.8 over 5.6, which equals 0.5. Now you refer to a chart of known RF values obtained under the same conditions, with ethanol as the solvent. The known RF value for red 40 in ethanol is 0.5. Since the RF value of your unknown substance matches the RF value of red 40, this indicates that the ink likely contains the dye red 40. Let's have a look at some questions. You are given the following chromatogram. Calculate the RF value for substance A. First, identify the given distances. So we have 5 centimeters, which is the distance traveled by substance A from the baseline. 4 centimeters, which is the distance from substance A to the solvent front. This is not a relevant measurement. 9 centimeters as the distance from the baseline to the solvent front, and 10 centimeters, the distance from the baseline to the top of the chromatography paper. Again, this is a measurement that is not relevant. Hence, the two relevant measurements are distance traveled by the substance, 5 centimeters, and distance traveled by the solvent front, 9 centimeters. We know the formula for RF is RF equals distance moved by the substance divided by distance moved by the solvent. Hence, the ERF value equals 5/9, which is approximately 0.56. Given the following table of standard RF values, identify substance A. Comparing our RF value to the table, we find that it closely matches the RF value of green 3. Therefore, the unknown substance is likely green 3. In today's lesson, we introduced the concept of RF values in chromatography. We learned that the RF value is a numerical measure of how far a substance travels on a chromatogram relative to the solvent front. We learned that it can be calculated using the formula: distance moved by the substance divided by the distance moved by the solvent. We discussed that each compound has a unique RF value in specific solvents, allowing for identification by comparing these values to known standards. By mastering this concept, you are now equipped to interpret chromatograms more effectively and use RF values to identify unknown substances. This knowledge will enhance your ability to analyze mixtures in both scientific and practical contexts. Watch the rest of the GCSE chemistry course at Sophos Education.